Okay, so one more time I'll just repeat this. Okay, so PEB structure is pre-engineered building. So it can be done in both RCC as well as in steel. Okay. So as per the bending moment requirements, will be curtailing the sections. So that is called the PEB structures. So if this is the portal frame, okay, and here both end it is fixed, okay, and here it is pinned, okay. So for this beam, the bending moment diagram will be this, okay, and for this column, the bending moment diagram, here more bending moment, at the pin there won't be any bending moment, zero bending moment here. So the bending moment diagram will be like this. So as a conventional method, we take what is the maximum bending moment and we design the same size everywhere. Okay. So that's the conventional method. So whereas in PEB section, so we size the section according to the bending moment requirement. So here the same thing I have taken, same fixed and pin condition. So the same, this is the bending moment. So this is the maximum bending moment here, and this is the maximum bending moment here, here minimum bending moment. So maybe for the maximum bending moment, here it is 300, here minimum bending moment, so it's 200. So it will be like a tapered section here. Okay, similarly here also the maximum bending moment here, and here it is zero bending moment, but we should not reduce, we should not make 0 mm depth here. Okay. So at 1 meter, what is the depth that we provide throughout this end? Okay. So here maybe maximum bending moment maybe 400. Here it is reduced maybe to 200. Okay. So this is the advantage and disadvantage of the PEB structure. Advantages, it's economical. Okay, material cost, material wise it's economical because there is reduction in the material section, so material will be reduced. Okay, steel section material also will be reduced, concrete, rebar, everything will be reduced. So material cost is reduced, and the disadvantages is costly in construction. Okay. So this is the price comparison just for the example, not exactly. So if it is 55,000 per ton, the material cost. Okay, so in this materials are reduced 50% here. So 50% material cost also will be reduced. Okay. Okay, but the construction cost for the fabrication erection, it will come around, in the normal case, it will come around 20,000 per ton. So the construction cost will be more, okay, due to making it as a tapered section, those fabrication, for the fabrication, the construction cost will be more. So it will be like 10% more, okay. So here the material cost is reduced 50%. So it will be coming around 25,000 per ton. So here 20,000 per ton construction cost is increased to 10% more. So altogether, if you account it, it will be more economical only because 50% material cost is reduced. So material cost is high compared to the construction cost here. Okay. So that way it is economical only. So now we'll model this in ETABS. So we can define this section property, a frame section. So for defining this, we should know what is the size. So I'm just taking some assumed sizes here. So the size, we have to assume initially as we do in normal designs, and then we have to do the analysis. If it fails, then we can increase the size. Okay. So I will do one tapered beam. So I'm just taking some random sizes here. So 230 by 400, and this will be like yes, sorry, 230 by 230. Okay. So this for beam we can consider this size, and next for the column. So this column here, more bending moment at the bottom like this. So here 230 by 500 for example, and here maybe 230 by 250. Okay. So similarly for the steel section also we'll model. So for steel section also we'll assume some steel I-beams. So we'll assume the sections. Okay. So this may be ISMB 400. Okay, and this may be ISMB 200. Okay, just for example. And this I'll assume as ISMB 500. And this is ISMB 250. Okay. So in the first we'll define this property. Define section property frame sections. So we'll add a new property, concrete. So beam. So this is start of this tapered beam. Okay, I'll mark this section as B start 230 by 400. So all these things you know how to give this. So depth is 400, width is 230. So modifiers, everything you can give same way. Just all these things you know. I'm just going to. So it's a beam. I'll change to beam. So rest all you can know give those properties. I'm just going to model alone. And new property concrete. It's the B end. This is 230 by 230. Okay, next column also will define. Column start. So this is start, bottom start, and this is end. So it is 230 by 250. Column end 230 by 500. Okay. So we have defined the sections. Now we have to define the tapered section. Okay. So we have to create this section, tapered section. We have to define this. So we can add new property. So for tapered section, you have to give non-prismatic. Okay. So you can select this non-prismatic. So here I'll give a property tapered beam. And here you can give what is the start section and what is the end section. So start section will be 230 by 500 beam start, and end will be this 230 by 230. Okay, you can give this alone. So remaining this parabolic linear, everything you need not give anything. So let it be. I will not change anything here. Just give the section. What is the start and what is the end section? Okay, and you can click OK. So tapered beam we have defined. Similarly, tapered column also we can define. So add new property, non-prismatic. tapered column. So what is the start section and end section you can give here. So for giving here we have already defined it. Okay, so now we'll draw this beam. So here we'll change the property tapered beam. So I'm just making this portal frame. Okay, so here from start till here there is a section break here. So I've drawn this portion, we can draw this also. So for that I'll define another tapered beam. So define section property frame sections. New property non-prismatic. So it's tapered beam 2. So this will be the start and end section. Okay, B start 230 by 400. Okay. Okay, I'll show this in rendered view. Something is wrong here. So I'll first show this in rendered view. There's a section change here, you can see here. Okay. Okay, now it is right. Okay. So next we will draw this column. Tapered column. So you can view this in rendered view. Okay, here more section is more here. Here the depth is less. So here it is reducing and now it is increasing here. Okay. So same thing you can do for steel also. So now I drawn PEB, RCC PEB. Same way you can model for steel also. For steel we can define frame section. So first we can import all the steel sections. Can just import. Okay. So now it's imported here. So we have to create the tapered. We have to define this. You have to define this tapered beam and tapered column. So you can add new property, non-prismatic. So it's a steel tapered beam. So start section ISMB 400, ISMB 200. Okay. Okay, start and end section. You can click OK. So this can be beam 1. So now it is defined. Similarly, you can add copy of property also. Steel tapered beam 2. So this will be ISMB 200. It's ISMB 400. Okay. Similarly, you can define column tapered, steel tapered column, prismatic, steel tapered column. So start ISMB 250 and ISMB 500. Okay. So in this itself, I'll just modify and show you the steel PEB. You can select. I'm just assigning that property to this section property. Tapered beam 1 can apply, and for this tapered steel beam 2, this 2 columns tapered steel tapered column. Okay. Okay, we'll view this in rendered view. Okay, so you can see this section. So here more, and it is here less, and here more. Similarly, this column is also like tapered one. More at the top and less at the bottom. Okay, so this type of PEB structures you could have seen. So here maybe more bending moment, so more depth here. So here lesser bending moment, so lesser depth. So and it goes on decreasing and increasing like this. Okay. So this is also kind of a pin connection only. Okay, you can see here. Maybe here fixed. Okay, so it looks like that. So, but the only the modeling is different. You have to define the section. You have to assign that. Okay, but rest all it is same only. So analysis and design part everything is same. So just the modeling alone, I just show you how to do the tapered section modeling. Okay, you can design and analyze the same way how we do for the other conventional structures. Same way you can do this. Okay. Okay, so that's all our course ends here. So anybody have any doubts? That is column to beam connection, right, sir? So same way you can do it, sir. Column to beam, have you not seen any column to beam connection? Mm. Yeah, beam to column we have seen, right? So same way you can do it, sir. So the example we have tried for beam to column, beam to beam. So with this you can practice some other connections also. Manual design, I think we have shared, sir. Foundation design with the axial force, moment, and horizontal force. We have done the manual design in Excel sheet, right? Yeah, design, that's what I told. Only the modeling is different, sir. Design and the analysis for PB is same only. So same analysis and design it will do. Um, there will be some connection between those two tapered beams, sir. I think it will be welded. Uh, so I'll confirm this in. I'll confirm this later, sir, about this. It will be generally welded only. So you are asking about the detailed connection drawings, right? So that is you mean the fabrication drawing or the structural drawings? Sir? So structural drawing alone will be prepared by the structural engineer, not the fabrication drawing. Uh, Okay, sir. I'll send you the sample connection detailing drawing, the structural drawing alone. Fabrication drawing will not be generally done um, by the structural engineer. It will be done by the construction engineers only. So I'll send you the sample drawing for some other building. I'll send you the connection drawing. You can see that because structural drawing will be easy to understand with the concepts, everything. I think you can able to understand. So if any other doubts, we can have one more class also for the doubts clarification. Okay, sir. Thank you all. Thank you for. How do you feel about this course, sir? Because this is the end of our course. If your mic is problem, no problem, sir. If you
Hello,
have,
ma'am. Can you hear me?
yeah, yes. Okay, sir. Yeah,
This course is very useful and practical. We achieved more practical knowledge from you. And if I have any doubts, you will clear. And
yes.
I mean, you have cleared all doubts. What we have.
Thank you, sir. Thank you.
Yeah, moreover, I think it's very useful as the students, and even he is working seeking jobs. Yeah, that's all.
Thank you. Thank you. So anytime you can ask doubts in this group also, sir.
Okay, ma'am. Thank you.
Okay, thank you. Thank you.
Thank you.